Good morning, students. In last video, we completed the third step of designing a learning system. Next, we are starting with the fourth step. Before going to that fourth step, here I show you that the checkers game, how it looks. This is the board game. Till now, whatever the examples we take is maximum checkers game and some driving example. We took this for these three steps. We are continuing mainly with the checkers game example only. That's why I show here I am showing you this board game, checkers game. So like this, red pieces are there and black pieces are there in this game. Rules already we studied in previous videos. So next step is the choosing a function approximation algorithm. For this, whatever the example we took to get the linear function, we have specified the some values, as well as here we are taking the same thing. As choosing a function for approximation algorithm, here we took the pair of values b and v of p. That is, v of p is the target function. We assigned some real values in previous steps for in second step. Go like this. See, if the b is the final state and that is the one state, then we are assigning the 100. And if it is a b is a final state, if you lost the game, we are assigning the minus 100 values. If it is a drawn, 0. If it is not a final state, we are assigning the some approximate value. Here we took the target function of v of p. In third step, see, we are giving the values of x1 and x2, how we what they represent. X1 is represented the black pieces on the board, x2 is represented the red pieces on the board, x3 represented the black kings, x4 represented the red kings. So x5 black pieces threatened by red, sixth one is red pieces threatened by the black. So in fourth step, we are using that example with these values of x to x values, and here we are given the linear function of approximation with the v cap b, not vb. Vb is the target function actually. Why we are going for the v cap of b here is it is the approximation function, because it is a approximation function. V of b doesn't give the exact values. Here in v cap b, why we are considering means we are assigning some real values for every move. If b is not a final state, then we are assigning the some optimization of real values to every step, every move. That move. So that are we are giving firstly approximation values. That's why here we are linear combination of these are all step present board state that we are representing with the v cap of b. And already we said w naught to w6, these are the numerical coefficients. In that w naught is the additive constant and w1 to w3 are the numerical constants, and these represents the relative features. So last class we completed with the partial design of checkers learning algorithm. This is the checkers board, red pieces, black pieces, and x1 represents the red pieces and x2 represents the black pieces. x3 represents the number of kings of black pieces. X4 represents the number of kings of red pieces. X5 represents the number of block pieces threatened by red, and x6 represents the this one only. Till now only we studied number of red pieces threatened by the black. Excuse me. So see, in this example, here we are taking the example in which game the black pieces player won the game. And that is the final state. So these are the b is the final state, and black pieces won the game. So that's why it is represented with the plus 100, won the game, plus 100. So target function value is 100, and here we are representing the x1, x2, x3 values. x1 is equal to 3 means at the present on the board 3 black pieces are there, and x2 is equal to 0 indicates that red has no remaining pieces. There are no red pieces on the board. x3 is equal to 1 means within the excuse me, one black king is there. x4 is equal to 0 means there is no kings of red pieces only not there on the board means kings are also not there in the board. x5 is equal to 0. Here black pieces are not threatening by the any red piece. Red pieces are not present on the board, that's why x5 is equal to 0. x6 is equal to also 0, same thing. Red pieces are not threatening by the black pieces because there are no red pieces on the board. So this is the final state. This is the example for this, and how they are representing the function means v value as well as with the v train value. V train target function value, that here it is represented like this ordered pair state comma and what is the real value assigned to that one. Because there is no red pieces means black pieces player won the game, that's why here they are applying the value of 100. So to choose the function for the approximation algorithm, if b is not a final state, there we need to consider the two things. The first one is the estimating the training values, second one is the adjusting the weights. So we are starting with the estimating the training values. First one is the estimating the training values. To estimate the training values and to assign the some particular real value to the particular move, here they are considering the value depending upon this step. V train of B, that is considering the values of V of successor of B. B is the present state actually. What is the B is the what is the present state of the board, and V cap successor B here we are considering. Successor B means if we move in this sequence, if we forwarded this in this sequence one step, what is the next step of the opponent depending upon the what is the step of our again this player step, that we can call as the successor step. That is means if we are considering board state is there, black pieces player is now black pieces player is playing the game and he is trying to move the one step up one piece, and then he is estimating that one what is his success step. That means he is imagining by this move opponent person will move the another red piece, depending upon that what is the next move of his black pieces player next move, that we can call successor one. So depending upon that he is assigning the some approximation of real value to the particular move, that is we can call as estimating the training values. For every step considering the successor of the B, that means what is the next successor denotes the next successor state. So that's why here I am saying once again V successor of B denotes the next board state of B. So this is about the estimating the training values. Next one is the adjusting the weights. What is weights? Till in the linear combination of the function that we are having the x1 and some coefficients. W0 is the additive constant and W1 to W6 are the numerical coefficients, that are all we are calling as the weights. Here to how they are adjusting the weights means every time. So every time they will adjust the weight depending to get the exact value for the weights, and it will give the proper training, and it will perform the proper training, and it will perform the it will design the proper learning algorithm. To get that one, it must follow the several algorithms are there to find the weights of the linear function, and here to minimize the error and to find the weights of the linear function. Here in this, following the one particular algorithm, specifying or following the one particular algorithm is least mean square. Least mean square. This is used to minimize the error. This is used to minimize the error. How they are calculating the error means V train B and minus the V cap of the B. Already we told you V train B is, if you know the final state, if you know the present state is the final state, you know the target value of the particular value, whatever the real value you can assign to that particular state. That is, if you lost the game means you are assigning the minus 100. If you won the game means you assigns the 100 value. If you know the particular real value to that one, that we can call as a V train of B. But V cap of B, we said that is the approximation value. Every time whenever you are assigning some approximation value to the intermediate board states, if it is giving the minimum error, every time whenever you are trying to learn by this, if you are assigning some values or you are continuing with your program, at the end of the game, if you won the game, then whatever the values you are assigned, that are the perfect values, then you will get the error 0. Like this, V train B and V approximation B, whatever approximation you took the value, that is equal to the particular real value, that is V train B. V train B and V approximation B both are same is minus, the subtraction of these two values will become as 0. That we are considering as a error. So here what we are considering, least mean square means every time they are taking that V train of B minus V cap of B to the power of 2. By this algorithm, least mean square algorithm, every time whenever you are trying to learn the game and assigning the some approximation value, and depending upon your final state, change the values of weights. Change the values of weights to get the minimum error. That's what here we specified this one. If error is 0, no weights changed. If the difference is the positive, each weight is increased in proportion to the value of its corresponding value, and if it is a negative, vice versa we are applying. This is about the adjusting the weights. These estimating the train values and adjusting the weights, these two steps comes under the fourth step of choosing the function approximation algorithm. Last one is the final design. This we can say as if last step. What is the final design of our checkers learning system is, naturally it is divided into the some district program modules, that are the 4 districts program modules. First one is the performance system. It is the module that must solve the given performance task. In this case we are considering the example checkers game means, by using the learned target function, by using the previous experiences, if it is performing very well, that we can call as the first module. Try to perform the very well, that we can call as a performance system module. So this is the diagram. Final design is divided into the 4 modules. This is the diagram. Performance system, and second one is the critic, third one is the generalizer, fourth one is the experiment generator. Performance system, now till now only we studied. Performance system took the learned target function values and performs very well. And whatever the solution came and game history is there, that is taken as input for the second module. Critic takes the input, the history or trace of the game, and produces the output, a set of training examples of the target function. Depending upon the performance, if we are performed very well in previous experiences, depending upon that history, it traces the game and produces the sum output. Produces as the output of set of training examples for the target function. Next one is the generalizer. The generalizer takes as input the training examples and produces the output hypothesis, that it estimates the estimate of the target function. Generalizer takes as input of the training example and produces an output hypothesis. Already you know about the hypothesis. It comes in probability statistics. That means in a hypothesis means depending upon our depending upon our task and our experience, we are taking the one statement as imaginary statement, that is some with the positivity and with the negativity, that we can call as the hypothesis. So depending upon that performance and critics, whatever that takes, generalizer takes that input as a training examples and it produces the some output hypothesis. Last module is the experiment generator. It takes the input, it takes as input the current hypothesis, whatever the hypothesis generalizer gives the current hypothesis, it takes it as a input and outputs a new problem for the performance system to explore. So whatever the current hypothesis is there, that it takes and it gives the new problem. Till now, whenever it is learning the game, till now whatever it is not came across the type of particular example or particular state of the problem, like in checkers game only, whatever the whenever it is trying to learn or trying to learn the checkers game by playing itself, by playing with itself, whatever the situations come across, it won't take that one. It takes the new situation, new board state, new moves, and it gives to the once again to the performance explorer. This is the round of system. So it gives the new problem, whatever till now it doesn't came across, that it takes the new board state and new moves, a new board state, and it gives to the performance explorer. Once again it performs that one depending upon that previous experiences, and it gives the try to give the perfect output. So this is about the final design state, and once again it is represented as like this. These are the summary of the choices in designing the checkers learning algorithm. So till now is specified with the example of checkers learning algorithm only. That's why we have specified the choices in designing the checkers learning algorithm. First, determining the training experience, and determining the target function, determining the representation of that whatever the target function is there or learned function, determining the learning algorithm with the function approximation values. After that, final one is complete design, determining the training experience and depending upon the game's against itself, because we took the experience taking playing with itself only. Games again it's against itself it plays and determines the target function depending upon the board value. It determines the target function depending upon the board values or board moves. It determines the representation of the learning algorithm. After that, it linear combination of 6 VHS is considered. What are the VHS in these steps we consider means number of block pieces, number of red pieces present at that board state, and number of black kings are there, how many number of red kings are there, and how many number of black pieces threatened by the red pieces and how many red pieces are threatened by the black pieces. That we can call as a linear function of 6 VHS. And after that, determining the learning algorithm by estimating the training values and by adjusting the weights, we found the particular function which will give the error 0. After that, we are designing the complete final design, that is the completed design. So this is the final one. Next topic is perspectives and issues in the machine learning. What is the perspective means? It involves the searching a very large space of possible hypotheses to determine the one that best fits the observed data. So it involves the searching a very large space of possible hypotheses to determine within that which will that best fits the observed data. That means here it takes the number of hypotheses. Within that, it chooses only the one which best fits the real observed data. And what are the number of issues are there in machine learning means which algorithm performs the best For example, in this different types of algorithms are there for adjusting the weights. We specified the least mean square algorithm, like that which algorithm performs the best and which type of sub problems are representation. Next one, how much training data is sufficient to design a learning system, and what are the prior knowledge is required when it is only approximately correct. So like that, if you know the what is meaning of hypothesis, and what are the least mean square algorithm or basic whatever the algorithm you want to use to adjust the weights or to estimate the train. If you are taking the example of this one, means you are you need to know about the rules of that particular game. If you are going for the example of driving, and what are the rules are there, where you are trying to learn, if you are learning in India and if you are learning in abroad, already we know about that traffic rules are different for every country. So like that, what is the prior knowledge, which type of prior knowledge is required technically as well as the domain knowledge, and what is the best strategy for choosing the useful next training experience, and how can learner automatically alter its representation to improve its ability. How can we can change the automatically, that is also one issue. So these are the issues in machine learning algorithms. Thank you. We'll meet in next video.